Good afternoon, students. Hello. Hold on, I need to do something on this thing. 1 second.
Morning, sir.
Yeah, morning. Where is it? All right. You can see the screen, right? Can see the screen. Let's check in. Somebody need to answer that they are seeing the screen, please. Just making sure that everything is good. They're not hearing me. Are you hearing me? Aiden, are you hearing me? Cara, are you hearing me? Something is wrong. Ashton, can you hear me? I don't see what is wrong, but nobody seems to be hearing me. So that person is here, so why nobody responding? Najee, can you hear me? It's not working.
Yes, sir. We hearing you.
So why me keep asking if you hear me and nobody responding? You guys are crazy. I've been here for about 5 minutes or so, a minute or more asking, can you hear me, can you hear? And nobody saying anything. I calling people by name and nobody answering. You don't make no sense me start teaching and I don't show that everything alright, you know. And I keep asking, can you hear me, can you hear me? And you all hear that nobody's answering. Oh boy. Ridiculous, ridiculous. I keep asking, can you hear me, can you hear me, can you hear me? And everybody hear me asking that and not one person open the mic and say yes sir. So I mean, so not come to participate in the class, none at all. What is sense? That's why from next week, you not come face to face. I don't do no more online. From next week, you not come face to face in the Saturday classes. I'm going to take this thing for a joke. Anyway, so I sent this paper in the group yesterday, and I gave, well, this college, all the questions on this paper, you should be able to do all the questions on this paper based on what we have already covered in the class. You should be able to do every single question on this paper. That's where we're at in this program. We're at the stage now where you can actually do a full exam paper. Right? Yes, there are a couple of things we need to go through and stuff, but generally speaking, you are in a position to do the entire paper, and we need to start doing that. Right? But I gave you the questions in a particular sequence based on how recently we did the topic. So the first question I told you to do was number 7, which is the most recent topic that we have done. That's this one. The pattern, sequence and pattern, and they have some reason and logic built in it. Alright, so let's start with that one. So this question says, a sequence of figures is made from lines of unit length and dots. It says the lines form a series of octagons and squares. So you can see these are the octagons and these are the squares out on the edges here. Alright. It says, and the dots, there are some dots placed at the vertices. So these are dots at the vertices. It says the first 3 figures in the sequence are shown. So we have figure 1, figure 2, figure 3. It says figure 3 of the sequence is shown by itself below. That's figure 3 shown by itself. It says add lines of unit length and dots to figure 3 to correctly represent figure 4. So that's what I told in class. That's what they've been doing. They've been giving you a start to figure 4. So they're basically giving us figure 3. Sometimes they actually give more than just the start, and expect you to finish it, right? But in this case, they've given us figure 3 fully, and they want us to know add on figure 4. So we need to look at how you go from shape to shape. What is it? What is the change? Now clearly, they are adding one of those octagons. And then after they add the octagon, so this was added to the first shape, and put it on in red. This octagon was added to the first shape. And then they put in the square in the corner here. That is what was added. Alright? And then as you can see, they add the dots. Every vertex must have a dot. So because I am on this device, I can literally just copy what is added from this shape, just draw it over this, and put it on here, because I can draw, rather than draw it from scratch. But you would have to draw it from scratch. But I'm going to use the technology that is in front of me. So I'm just going to trace over this shape what is added. So this that is added. This is what is added. Or if you like, you could say that is added. Right? And this was also added to the origin, to shape 2. This is what was added to shape 2. And then the dots were also added. So I'm putting on what was added to the original shape. So you can say this that I've drawn in blue is what was added to this shape. Right? So the same thing is going to be added down here. Right? So I'm just going to use the technology and just going to move this out and put it down here, because I can. So I'm going to move what was added and just put it down here. That's where it must go. No. Oh, so I left off one thing that was added. So this little line was added as well. So I'm going to put it on. This little line was added as well. This line. And this line. Alright, that is what was added. So I'm just going to move this down here. And there you go. So that in blue is what you'd have to add to this diagram to complete figure 4. Obviously, right? That is it. We need one more dot here, and we need another dot here. Alright, so that is it. Everybody good? That's our figure 4. Everybody good with that?
Yes, sir.
Alright, beautiful. Then we come to the table, which they always give us. And this information up here is always the same on basically every exam paper. Different things they're talking about. Basically, the information is generally the same. It says the number of dots D and the number of unit lines that form the perimeter of a shape P form a pattern. So the number of dots and the perimeter form a pattern. The values of D and P for the first 3 figures are written in the table below. Study the pattern of numbers in the row in each row on the table, and then they want us to complete the rows for number 1, 2, and 3. In other words, they want us to complete these 3 rows, which is how these questions are always set. Now, the first thing you want to do is look if this is one of the typical questions where they are adding the same number of things as you go from shape to shape. All right. So if you look in this column, you're adding 8. That's a plus 8, and then that's another plus 8. So this column is a plus 8 column. And in this column, they are adding what? They're adding 6. So here you added 6 plus 6, and then you added 6 again. You have to ensure that it is consistent. So once you realize that they're adding the same number of items, in this case dots, and they're adding the same number of lines to form the perimeter, then the formula on the bottom line can be easily written. And sometimes if you can complete the formula line first, then it helps you to complete these other lines. Now, this number 4 is actually absolutely the next shape after number 3. So we can continue the trend for these 2 by adding 8 and by adding 6. Right? So those 2 kind of easy. This one is kind of easy for that reason, because 4 is the next shape. If this was 5 or maybe 6 or maybe even any other number, this one, then basically you want to use a formula down here to help you. Alright? But you have a choice. But let's do the formula line first, because this is going up by 8. I know that 8n starts a formula. 8 times n. The formula must have an 8n in it. And then because the first figure is 8, when the n is 1, 8 times 1 is already 8. So there's no need to be adding anything to this column. So this column is just 8n. 8 times n. Alright? So this column is just straight 8n. So don't put it in the middle. You can see it here. So 8 times 2 is 16. 8 times 3 is 24. And then it will be 8 times 4 is 32. So next figure is 32. Whether it is that you want to add the 32, add 8 to the 24, or use a formula. 32. Then this column, everything is increasing by 6. You're increasing by 6. And so the formula starts with 6n. But the first figure has 8 in it. In the first figure, n is equal to 1. 6 times 1 is 6, but it's 8 we have, and therefore we have to add 2 more. So the formula down here becomes 6n plus 2, because you have to add 2 more, to get the 8 in the first shape. And if you like, you can test it in the second row by putting 2 on the formula here. 6 times 2 is 12. 12 plus 2 is 14. So you know the formula is correct. Right? Formula is correct. And then now, again, because this is the next shape, you can continue the trend of adding 6. So this will become 26. Or you could take the 4, put on the formula. It will be 6 times 4 is 24. 24 plus 2 is 26. So anyway you want to work it out, this figure is 26. Then on this line, what it is that they have given us this number. And all we have to do now is equate that number to this formula to see what the n is. Alright? That's the way we do this. Alright? Just to put the formula equals 86. So for this row, to get the value for here, the n for here, I'm going to equate 6n plus 2 to 86. So I'm going to get 6n plus 2 equals 86. And I'm solving for the n right here. So I'm going to subtract the 2 over here first. I'm going to get 6n equals 84. And I need to divide by 6. So 84 divided by 6, 14. So n equals 14 when I divide by the 6. Alright, so right here the figure n is 14. This thing is messing me up. This is 14. Pen is giving me some problems, guys. Pen is giving me some problem. I'm gonna try another pen after this. Maybe let's use my finger. Let me see. 14. In order to know that that is 14, you can take this 14 and put it on the formula 8 times 14 to know what this cell is. And so that's 8 times 14, that's 112. 112. Alright, so far so good? But okay with
Yes,
that?
sir. Yes, sir.
And down here it says no, for any figure n greater than 1, right? So in other words, for any figure down here, n greater than 1, because when n equals 1, these two figures equal. The dots and the perimeter equal, right? So down here, after you pass 1, that's what they mean here, for n greater than 1. So for any figure where n is greater than 1, the number of dots is greater than the perimeter, as you can see, right? The number of dots is greater than the perimeter. The number of dots is greater than the perimeter. So there's a difference. So determine the value of n for the figure in which the difference between the number of dots and the perimeter is 36. Right? They want to know what the value of n is. So what we want to do is get a formula for the difference. And we have to put it equals 36. Or we can say it is when the number of dots formula minus the perimeter formula is equal to 36 and solve for n. That's all we have to do. That's what this is saying. So it's when 8n for the number of dots minus the perimeter. You have to put the perimeter now in bracket 6n plus 2. When that difference is equal to 36. That's what you're solving. So it becomes 8n minus 6n. That's 2n. And then this is a minus 2. Open the bracket, you're going to get a minus 2 equals the 36. You can take this minus 2, bring it over here and add it. And you get 2n equals 38. And when you divide by 2 under here, 38 divided by 2 is 19. The n equals 19 when you divide 2 by 2. And so that is the figure n for which the difference is going to be 36. But understand that working out? Very good with that?
Yes, sir.
Alright, good.
Yes, sir.
Let's move now to number. The second one I gave you, I think, was a statistics question, because that's a topic that we did recently as well before this one, right? So I think I gave you the statistics question on this paper. It's probably number 6 actually. No, number 5, right? Number 5. So I think I gave you this one next, number 5 to do. Right. That's it. So they gave us this diagram. It's a cumulative frequency curve. It says the cumulative frequency diagram below shows information about the distance d kilometers that each of 120 students walk to school on a particular day. So let's analyze this, guys. Remember that these are the 120 students. The ones who walk the shorter distance are at the bottom, The ones who walk the longer distance are at the top. This is the best way of arranging the data in ascending order from the ones who walk the shortest distance up to the ones who walk the longest distance. And these are the distances that they walk less than. Remember now, this cumulative frequency graph comes from group data when you don't know the actual distance walked by the students. Right? And it's the best way of lining out the students, or the best way of simulating and lining out the students from the ones who walk the shortest distance to the ones who walk the longest distance. Because you don't know the actual distance that they walk, you can know how many students walk less than any distance down here. So even though they don't put less than on here, right, it is less than distance. That's what it is really. It can also be less than or equal to distance, one out of the two. Less than or less than equal to distance. Or you can know sometimes is by the question, or you would know if they had put the points on the graph, and the points were at the 0.5 marks, at the upper boundary marks. But most time it is less than, so let's assume it is less than for now until we read. If it shows to be less than or equal to, then fine. And then it won't be a major difference anyway, because everything you do is an estimate, because the data is from group frequency distribution. And once you're doing group frequency distribution, everything you do is an estimate, for the simple reason that you don't know the actual distance walked by the students. That's why they use a cumulative frequency curve. If they knew the actual distance walked by the students, there would be no need for a cumulative frequency curve. All right. So this first question says, how many students walk at most 1 kilometer to school? Now, what does at most mean? It means that 1 kilometer is the most, right? So at most 1 kilometer means less than or equal to 1 kilometer. So therefore, based on this question, I'm going to assume that this is a less than or equal to graph. It will tell me how many students walk less than or equal to any distance. All right. So the first thing we have to do is understand what at most means. It means that 1 kilometer is the most. So you want to know how many students walk 1 kilometer or less. So this is a less than or equal to graph. It will tell you. And to do that, then all we need to do, right? First, after understanding that this means less than or equal to 1 kilometer, this means less than or equal to 1 kilometer. We can write the answer from the graph over here, the number of students. I'm going to write it over here. Alright, so to do that now, you find 1 kilometer, and it will show you how many students walk less than or equal to that. So you come up on the graph at the 1 kilometer point right here to this point, and you read it across. It is right on this line right here. This line right there. And then you don't just go reading, you make sure you understand the scale of the graph. I should have done that first actually. We need to understand the scale of the graph before we start. So there are 10 lines in between here, between 0 and 20. There are 10 intervals. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 intervals for 20 students. 20 students divided by 10 intervals. That's 2. It means that each of these little intervals is 2 students. You have to establish the graph first, right? So each of these little intervals between these little lines, that's 2 students. And you can see it now. Look. 2, 4, 6, 8, 10. This will be 10. 12, 14, 16, 18, 20. So I have to establish the scale of the graph before we start to work. Right? And if you like, you can put these in. This is 10. This is 30. So this is 32, 34, 36. That is 36. So I'm going to say 36. This is 36 right here. So 36 students walk less than or equal to 1 kilometer. So the answer here is 36 students. But understand that?
Yes, sir. Yes, sir.
Alright, beautiful. Next question says, using the graph, use the cumulative frequency curve to determine an estimate. Just remember, everything we do when the data is grouped is an estimate. You don't know for sure. You don't know the actual distances that the students walked. The median. Now, first to find the median, you have to find the position of the median and then see what that median distance is. All right? So the median is the distance that half of the students walked less than or equal to, or walk less than. All right? And it's just an estimate. Now, since there are 120 students, the halfway mark, or the student in the halfway position, will be the 60th student. Half of 120, half of 120 is the position of the median, which is Q2. The median is the second quartile. The 60th student. Alright? That's the position of it. That's not the median, you know. That's just the position of the median. So, let me use the red ink for here. So, 60 is the position. Let me write out here. Position of Q2 is the 60th student. So, you come across on the graph and you read this line down. And then we're going to make sure that we get the scale of the horizontal axis correct as well. So coming on this line, read that all the way down to here. So talking about this mark right here. So we need to make sure that we get the right scale. Alright, now let's look at the scale now. There are 10 lines again, up to 0.5 kilometers. Remember, this is 0.5 kilometers. There are 10 intervals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 intervals. What is one of those intervals equal to in kilometers? 0.5 divided by 10. That's 0.05. Alright? Or you can say every 2 intervals is 0.1. You could say every 2 intervals is 0.1. So this is 0.1, 0.2, 0.3, 0.4, 0.5. Get the scale right. Every other interval is 0.1. Alright? You have to understand that. So it means that, what's this position right here then? This is 1. This is 1.1, 1.2. This is 1.3. This will be 1.4 and then 1.5. So you know that this is really 1.3. So this Q2 is 1.3. So let me put it on it. Put it on it that this is Q2. Right, let's write it on it. This is Q2 that we have found, Q2, and it is 1.3. Alright, 1.3. I can write it down here too. I can put it down here. This is Q2 that we have found, this 1.3. 1.3 kilometers is the estimated median. And it's on the graph, so I just have to write it here, 1.3 kilometers. So remember, 60 is not the median, that's the position of the median. Then now they want the lower quartile. So first you have to find the position of the lower quartile. And look at it 2 ways. It is a halfway mark between the 0 and the 60, which is 30. Alright? Or it is 1/4. That's the position I'm talking about now. The position of Q1. Lower quartile is Q1. It's 1/4 of 120. That's a 30th student. Alright? As I said, it's halfway between 0 and 60 is a 30. So then, let me put this in red. This is the position of Q1. Position of Q1 is this. That's not the Q1 value. That's just the position of it. To get the first quartile itself, now you come across on the graph until you reach the graph right there, and you read it down. Let's do it accurately. Read it down. So you're on this line right here. Right there. That value. So remember, every other line is 0.1, right? So this is 0.5, 0.6, 0.7, 0.8, this is 0.9, and then this is 1. So this is 0.9 right there. That is your Q1, 0.9. Right, come down here, I'm going to write it. So this is 0.9 kilometers. See, I'm putting in the unit, guys. Right? Don't leave out the unit of your measurements. 0.9 kilometers. And I have it on the graph. It's only one mark for it, you know. So I've indicated how I've gotten it on the graph, because I'm leaving all these things on the graph, and these lines that I'm putting, I'm leaving them on the graph for the examiner to see how I get it. The only difference is that I want to draw these lines with straight lines. Use a ruler to draw those lines. You won't draw a 300 line. Alright? So that is 0.9. And now they want the interquartile range. Remember, the interquartile range is Q3 minus Q1. We know Q3, we know Q1 already. This is the Q1, we have it already. We therefore need to find the Q3 in order to do this calculation. Alright, we need to find Q3. So we do the same way. Q3 would be the halfway mark on the top half of the data. Halfway mark between the 60 and the 120. Or it is 3/4 of the total number of students. 3/4 of 120. That's 90. Alright? So anyway you want to look at it, it is the 90th position. So the portion of Q3 is right here at 90. So this becomes the position of Q3, position of the third quartile, is the 90th student. To get that measurement of the 90th student approximately, come across on the graph same way on the 90th line, come to this point right here, and then so on this line. That's the mark that we want. Right, we're on this one. Don't mind me. My device can't draw straight lines, right? So just bear with me. I can't turn this into a straight line with this device. Don't allow me, I did not come with a stylus. Alright, that mark there. So be careful now. This is 1.5. This will be 1.6. So this is 1.55. Halfway between 1.5 and 1.6 is 1.55. So this mark is 1.55. I did say every interval is 0.05. So that is 1.1, 1.55. Right? That's what the Q3 is. This is Q3. 1.55 right there. Alright? So coming down here now, I'm going to do the calculation. The Q3 is 1.55. So the calculation here becomes 1.55 minus, and Q1 is 0.9 for the interquartile range, not the semi. They wanted the semi-interquartile range. We have to divide this result by 2. So let's just do it. 1.55 minus 0.9, and that's 0.65. Remember, put your kilometers on it. Alright, put your kilometers on it. All these measures are in the unit of the data. 0.9. But I got it that so far? But okay?
Yes, sir. Yes, sir.
It says now, a student is chosen at random. What is the probability that the student walked for more than 1.5 kilometers? You want a student to walk for more than 1.5 kilometers. Alright? Now, to find the students who walk more than 1.5 kilometers, you have to first find the number who walk less than or equal to 1.5, because that's what the graph will show you. And then it is the rest of them above that. The rest of them above that would have walked more than 1.5, because the graph will show you how many walk less than or equal to 1.5. Alright? And so this is also confirming that this is less than or equal to the graph that we have. So it's going to go and find 1.5 on the mark, on the graph. See how many walked less than or equal to 1.5, and the rest of them would have walked more. Alright? So that's all we have to do. And then now remember, it's a probability we're doing, you know. So we put that number of students now over the 120. Alright? And that is the probability, because the number of favorable outcome out of the total possible outcome. So total possible outcome is 120 students. So let's look how many did less than 1.5 first. Less than or equal to 1.5. So let me just show the calculation now. Less than or equal to 1.5 kilometers was done by how many students? Let's see. It's going to find the 1.5 mark. See it here? This is 1.5. There's a different color for this one. This is the 1.5 kilometers. Right? And then you come up on the graph at 1.5. Today we take the curve. So you can see how many students walk less than or equal to 1.5. And it looks like it is right here when we zoom in, right here. Right there. And we'll come across on the graph. Come across. And that looks like 82. Remember, every one of these little lines was 2, right? But I put it down here now, just to ensure that we don't forget. 2. So that every interval like that is 2. Right? So it means then, don't go make the mistake and put this as 81 now, you know, because that is actually 82. This is 82. So 82 students walked less than or equal to 1.5. So the rest of them, 120 minus 82, is the rest of them up here at the top that walked more. See there? Corresponding to this part of the graph up here. So corresponding to the distances over here. Over here. So these are the students at the top, corresponding to the distances up here, which are greater than 1.5. So that confirms the question is asking about the students above that 82 students. So it's 120 minus 82. That's the number of students who walked more than the 1.5. One's at the top. So see it down here now. So less than 1.5 was walked by 82 students. So greater than 1.5, more than 1.5, meaning greater than 1.5 kilometers, was done by 120 minus 82. How much is that? 120 minus 82. That's 38. So 38 students walked more. So the probability that they want right here is equal to the probability that they want. Alright, let's put it this way. The probability of greater than 1.5 kilometers is going to be equal to 38 divided by 120. And I would leave this working out on my paper. I'm not moving it. I'm leaving it down here. So the examiner can see where I got my 38 from. Alright, so it's 38 over, I can simplify it, 38 over 120 as a fraction in simple terms. That's 19 over 60 right here. 19 over 60. So yeah, that reduces to 19 over 60 in lowest terms, right? 19 over 60. That's a probability left as a fraction. Very good. That's it. Question done. You done? No, it have another part. Not done. It have another part. Very good so far?
Yes, sir.
Good. That's another part. Let's go. So down here now says, complete the table below and use the information to calculate an estimate of the mean. See, we are estimating the mean again because the data is grouped. So what it is now, they have now given us the groupings, right? And they have also given us the midpoint values. Remember, I use the midpoint values to represent the group when you don't know the actual data. So we need to fill out these values and then estimate the mean, right? So remember, the mean, when the data is grouped, becomes the sum of fx. This is the fx column, which I call the sum column It's a column where you're able to sum the values divided by the number of values. And the number of values is always the sum of the frequency. That is supposed to be the same 120 students, right? Alright, so we need to complete this thing. Alright, so we're going to have to figure out the number of students in these two intervals. Alright, from the cumulative frequency, because we don't have it. We're going to have to figure it out from the table, from the graph. Alright, because we don't have it. Now, firstly, the midpoint kind of easy. You can see that they're basically increasing by 0.5, right? Right? Look, these values going up by 0.5. This lower limit going up by 0.5. Those are actually boundary values going up by 0.5. And so the midpoint will also increase by 0.5, right? So this right here is going to be 1.75. This is totally no calculation. Just add 0.5. Because everything increasing by 0.5. Alright? And then to get this value now, we can basically go on the graph and see how many students were there between 1.5 and 2. Right? And then we can see how many students were between 2 and 2.5 on the graph. So I'm going to show you do that now. Alright? Let's show you do that now. So how many students between 1.5 and 2? So let's go on the graph. We already know what 1.5 gave us. I just worked it out a while ago. 1.5 gave us 82 students, right? So we need to see what 2 gave us now. And then it's a difference between them. So where's the 2? So the 2 line here, this is 2. And this is 2.5. We can just work out all of them from now. We're going to need all of them, right? So 2, let's see what 2 corresponds to. So come on the graph, this is the 2 line. I'll come up to the 2 line. Comes right up in between here. So I'm going to say it's right in between these two. In between, right? I get that number of students, right? Let's see what that is. So this is 100. This is 110. This is 110 right now. This is 112. This will be 114. This will be 114. This one. And this is 112. Right? You're between 112 and 114. So you're 113. So this is actually 113. 113 is a 2, right? Remember that the 80, remember that the 1.5 is 82. And then let's work out what the 2 was. So we can have all those figures at our disposal. So for less than 2.5 kilometers, you have to come up on this line to the graph. See what it is. I want to basically take the difference between them, and that comes up to there. And you come across here. That clearly is 118. This is clearly 118. 2 below the 120 is 118. Alright, that's 118. So then we can say, right, the 1.5 corresponded to 82 students. 2.0 corresponded to 113 students, and 2.5 corresponding to 118 students. So we're just taking the difference between those to know what the intervals were. Alright, so copy this down. So I'm showing you now how you can pull information from the graph for your table to know what the number is in any interval. Alright, so put it down here. Down here, paste it down here. Right, so the interval between 1.5 and 2 is inside here. So that's 113 minus 82. 113 minus 82. So that's 31 in there, 31. So in the table, we have to put 31 here. Then the interval between 2 and 1.5, between 2 and 1.5 is the difference between these two numbers, which is clearly 5. Right? 113 from 118 is 5. So there are 5 students in this interval. And you can double check it now, because when you add up everything here now, you're supposed to get the 120. Alright? And let's just double check that and make sure. So it's 12 plus 24 plus 46 plus 31 plus 5 plus 2, 120. So you know that these figures that you have implanted in there is correct. So I hope you see how I got those figures from the table, guys. Alright, just find the marks, upper boundary and the lower boundary. Alright, boundary you're using, the upper boundary and the lower boundary. Alright, and then now you see what the intervals are, difference between the values on the intervals. That's all you have to do. Alright, so watch over about the video and try it yourself if you don't fully get it. Alright, but those are the values. Let me leave this down here. So leave it over here. Get smaller and leave it over here. Alright. And then now we need to complete these two. Or we complete those and multiply these values. So multiply these two to get this. And multiply these two to get this. But that's the fx column is. We have calculated the total distance by all the students. Alright, so we're doing this column, this row first, which is 1.75 times 31. That's 54.25. 54.25. And we're doing this one, 2.25 times 5. 2.25 times 5. That's 11.25. That's 11.25. And then we're adding up everything here now for the sum of ff. So the sum of f right here, which is the number of values, is going to be equal to 120. And then over here now, we have the sum of fx, which we're adding up all these values now. Just like we're estimating the total distance of all the students over here. So we're going to add them up now. So it's 3, this is 3 plus 18 plus this 18 plus 57.5. We just added this 57.5 plus 54.25. This 54.25 plus 11.25. We just added this 11.25, and then we add the last value down here, which is 5.5. That's 149.5. Let's check, make sure all the figures are correct. 3, which is same as 3.0, 18, 57.5, 54.25, 11.25, 5.5. Everything is added. So I get it 149.5 kilometers. 149.5 kilometers is basically the total distance walked approximately by all 120 students. And so the mean distance is the total distance by 120 students divided by the 120. That is the mean distance walked, which is in this calculation here. Let's put it down here. So it becomes equal to 149.5 kilometers divided by 120 students. That's the mean distance walked by the students. So it's 149.5 divided by 120 students. That's when we write 3 significant figures. I just put the 4 figures. 1.246 approximately kilometers. It's an estimate, you know, see? It's an estimate, so could have just put the 1.25 or something like so. But that's okay. That's the answer right there. But okay with that? But okay?
Yes, sir.
Alright, good. So the next question we said we were gonna do is said number 7, number 5, and I said number 6, which now is a measurement question. Number 6 next, which is this one, right? So this is our solid geometry question. Alright. So this question says, at a track meet, a cylindrical container fitted with pipes as shown in the diagram below is used to serve water to athletes. Now when you get a question like this, just picture the thing and just make it realistic. The more realistic you can visualize it, is easier it will be. Put the realness in it and make the question become easier for you to do and understand, right? So they have this cylindrical container fitted with pipes as shown in the diagram below, and it's used to serve water to athletes. It says the cylindrical container is of radius 12 centimeters. See it here? 12 centimeters. That's a cylindrical container. Right? And the height is 20 centimeters. And it says is completely filled with water. So this thing is completely filled with water. So we can know what the total volume is starting with. Completely filled with water. And the pipes fitted at the bottom dispenses water into cone-shaped cups. So these are the cone-shaped cups, right? And everybody know these little cone-shaped cups and water dispensers. So this is supposed to be familiar with this. It says the cone-shaped cups have a radius of 3 centimeters. See it here? 3 centimeters and a height of 8 centimeters. And that's a cone. Right? It says calculate the volume of water in the cylinder in liters. Write your answer to 2 decimal places. Now, because we're working in centimeters, we are going to have to calculate the volume in centimeters first. And then we convert it to liters, noting, as they have said here, that 1,000 liters, 1,000 cm cube is 1 liter. So it means that when we get our answer in cm cube, we have to divide it by 1,000 to get the answer in liters. Now here notice they have not given us the formula for the volume of a cylinder, but I think it's on a formula sheet. Let me see. Which is pi r squared h. So, it's good to just know that rather than to be depending on a formula sheet. See here? Volume of a cylinder right here. See here? It's pi r squared h. Alright. Do they have the volume of a cone on here? No, they don't have the volume of a cone. But they have this formula. Volume of prism. Now, cone is a kind of a prism. Because 1/3 the area base times the height, and the area base will be pi r squared, right? That's for the cone. But the cone is a kind of prism with a circular base. A cone is a circular base prism, really. Not prism, pyramid. Pyramid. Circular base pyramid. And that's the formula for the volume of a pyramid, not prism. Alright, so you should know them. You should know these. It's all the formula on this formula sheet that you see on past papers. It makes sense to just learn and know all of them. Just know them and put them all in your head. Rather than to be go searching for it in an exam room. Just make sure you know all of them. Right? Put them in your head. Okay, you know you're going to use them at some point. Or there's a likelihood that you will have to use them. So just know what you need to know. So anyway, they want the volume of the cylinder in liters. Let's work it out. So it becomes pi r squared h. Which then is pi. Did they tell us what to use for pi in the question? Let me see. They don't tell you what to use for pi. Just use a normal pi on the calculator, right? Alright, yeah, let's use the pi on the calculator. So it's pi times, we're talking about this thing up here. The radius is 12 and the height is 20. So it comes pi times 12 squared times a height of 20. You get that in cm cube first. And you're going to divide by 1,000 to get liters. Alright, so let's work that out. So we're going to use the pi on the calculator. Use the pi on this one. Pi. Pi times 12 squared times 20. That's pi r squared. So we're getting 9047.7 79. And that's cm cube. But I want liters. So divide this now to get liters. So the volume is equal to this number over 1,000. And we get that it's going to be in liters. So you divide this now by 1,000. And it is 9. What they said? They said 2 decimal places, right? 2 decimal places. So it's 9.05 liters. 9.05 liters. Remember now, if you're doing any question going forward, you still have to work with the cm cube, guys. Right? You cannot use it. If you have to use that volume in the subsequent part of the question, you still have to use the cm cube because you're working in centimeters. All the dimensions are in centimeters. You cannot be working in liters and cm cube at the same time. So if you're using the volume going forward, you still have to use this figure. Alright, let's see. Next part now says water flows from the cylinder along the pipes into the cone cup at a rate of 7.8 milliliters per second. Now, let's process this information here. Now, one thing I can tell you guys is that a milliliter is 1,000th of a liter, and a cm cube is also 1,000th of a liter. So then 1 cm cube is the same as 1 milliliter. So when I give it this 7.8 milliliters per second, it is also 7.8 cm cube per second. That's the first thing I wanted to appreciate. Because a milliliter is 1,000th of a liter. And also cm cube, remember 1,000 cm cube is a liter, you know. So a cm cube is 1,000th of a liter, same way. So a milliliter and a cm cube is the same measurement. So when they give you milliliters, they are at the same time giving you cm cube. So the 7.8 milliliter per second is actually 7.8 cm cube per second. That's what this is. Same way, 7.8 cm cube per second. Also, let us process this information a little bit deeper. It is not complicated. All it means is that every second, this amount of water flows. So in 2 seconds, 2 times this flows. In 3 seconds, 3 times this flows. In 4 seconds, 4 times this flows. That's all it means. Every 1 second, this amount of water is flowing. It's not complicated. That's what that statement means. Alright? So think of it that way, and the question becomes a lot easier to process and deal with. Alright. It says calculate the time taken to fill one of the empty cones. Right? Time taken to fill one of the empty cones, and give your answer correct to the nearest second. Watch this now. What we need to know is the volume of one empty cone. Divide that volume by this amount, and that's the number of seconds that you take. You want to know how many of these 7.8 cm cube is in 1 cup full. Because remember, every 7.8 is a second. So if you know the total volume to fill the cup, and divide it by the amount that pours every second, then you will know the number of seconds. Right? So the number of 7.8 cm cube that is in the cup is the number of seconds it will take to fill the cup. So first we need to find out what the volume of the cup is. Alright? And they're helping us here. See? They're telling us that the volume of a cone is 1/3 pi r squared h. Now remember, we have to use the dimensions of the cone. So for the cone, the r was 3 centimeters and the h is 8 centimeters for the cone. Alright? Remember that now. So we cannot use the wrong dimensions. Right? The cone was 3 and 8. Let's make sure it's there. 3 and 8. And so the volume of the cone, using this formula, is 1/3 pi times the radius squared, which is 3 squared, times the height of the cone, which is 8 times 8. That's going to give you the volume in cm cube. Alright, so let me shift this over a bit. Alright, let me shift this over. So getting the volume of 1 cone, 1 full cup. Alright, so it becomes 1/3 times pi times the radius squared, 3 squared, times the height, which is 8. And we're getting 75.39 something, right? And that's gonna take out the calculator. That's 75.398 cm cube is the volume. All right. So if you're putting 7.8 every second, you want to know how many 7.8 is in this. So the time to full, the time to reach this volume is the time to full, become this full volume of 75.398 divided by the amount that goes in there every second, which is 7.8. Whatever that works out, you're going to get it in seconds. Because it's like you're counting how many 7.8, how many 7.8 you can get out of this. How many 7.8 mils or cm cube you can get out of this. Because for each of them is 1 second that flows. So I'm going to divide this figure now, that's on the screen, by 7.8. And that tells me 9.66. Now what did they tell us? They said give your answer correct to the nearest second. So it means they must correct to the nearest whole number. So if I get 9.67 seconds to the nearest second, that's 10 seconds. That's what I mean by to the nearest second. Carry it up to the nearest whole number. Run it off to the nearest whole number. So it takes 10 seconds to fill a cup, a cone cup. But understand that? But understand the calculation?
Yes, sir.
Alright, this one says determine the number of empty cone cups in B that can be completely filled from the cylindrical container. So remember, one cone cup holds this amount. And the volume of the whole cylinder was what? Where is it? This. So we have to divide those to see how many cone cups you need. Because every cone cup is holding this amount. Right? So all you have to do to know the number of cone cups that you need is divide the total volume in the cylinder by the volume in a cone cup to see how many cone cups you need. Divide those two figures on the screen. Volume of the whole cylinder divided by the volume of the cone cup. I'm going to clear. By that standard reasoning? By that standard?
Yes, sir. Yes, sir. Yes, sir.
Alright, so this figure up here is, I'm going to just copy it down. Let's use it power of my device. Copy that down. So it becomes the volume of the whole thing, the volume of the cylinder. So I'm going to write here. So equals, and just paste it here. Write a little formula. It becomes the volume of the whole coat, the volume of the cylinder, CYL, over the volume of one cone cup. That is the number of cone cups in it. So that's the volume of the whole cylinder, and the volume of a cone cup was this. This one that I have here. 75.398. Alright. And you have to go to the nearest whole number. You know why you have to go to the nearest whole number? Because it says, not the nearest whole number. You can't run it up, you have to run it down to the number of whole, to the nearest whole number. Because it says how many will be completely filled. So you need to point something that you get after this. You're not including that. I say how many will be completely filled. Alright? So whatever fraction you get after this, you have to ignore. So I'm gonna use 9047.79 over 75.398. So I'm getting 120 point something, so I know it's 120. 120. Right? The 0.0039 on the screen, it means that there'll still be a little bit left in there. To still be a little bit left in there to when you finish filling 120 cups, still be a little bit left in there. That's 120 cups you're gonna full. We could have also divided the formula, guys. could have also divided the formula, could have used the formula for the volume of a cylinder, which is pi r squared h for the cylinder over pi r squared, a third pi r squared h for the cone. So this is for the cylinder, this is for the cone. So we could have used those values. So the pi's would cancel. If you look at it, at the same pi's would cancel, and you would have the radius of the cylinder was 12 squared, and the height of the cylinder was 20, divided by 1/3. The radius of the cone was 3, and the height of the cone is 8. And I'm sure if you do this calculation, you're going to get the same 120. Let's see. So it will be a fraction 12 squared times 20 over 1/3. And now here, so 1/3 times 3 times 8. What did I get there? What did I do wrong? Oh, I need to square this. I need to square this r, pi r squared. I need to square this r right here. So I need to square this right here. It's a third pi r squared h. So I need to square this 3 square, right, to get the 120. See me? 120 cups. That's it. Could have done it that way as well. Stand done. So guys, if you didn't do it, go and do it over by yourself. It's a nice measurement question, this one, alright? Using the solid geometry stuff that we have learned in class. Alright, body okay with that? Body good?
Yes, sir.
Alright, so let's see what was the next one I want you to do. Let me see. The next one I told you to do was number 3. Number 3. It's another measurement question. Let me see. Number 3. I think it was a plane. Number 3. This one, right? The topic that we did recently as well, right? Alright. This question says, the box below contains the name of 5 quadrilaterals. Alright, so we have, remember, quadrilateral is a 4-sided polygon, right? So we have a trapezium, which has 1 pair of parallel sides. We have a rhombus. A rhombus is a parallelogram with 4 equal sides. We have a kite, is a quadrilateral with adjacent equal sides like that. That's a kite. Adjacent equal sides. Then we have a square, but I don't know a square. 4 equal sides, 4 equal angles. We have a rectangle. This box is a rectangle. Everybody knows what a rectangle looks like, right? It says, choose the name of one quadrilateral from the box that best completes each statement. It says a something has no line of symmetry and has rotational order of symmetry. Rotational symmetry order 1. Oh Lord. I've not done rotational symmetry in the class. I'm not done. So we can briefly explain rotational symmetry. So rotational symmetry is basically you measuring or counting how many different positions a shape can be rotated in to have the same as the original shape, right? So like for example, let's use an equilateral triangle, right? So with 4 sides equal, with 3 sides equal, sorry. And let's say this point is A, this point is B, this point is C. And what we're going to do, we're going to rotate it and see how many different positions it can be in, such that the dimensions or the orientation is exactly as the original one, right? And that's how you count rotational symmetry. So I have 1 here. And if I rotate this over, right, and make the A come down to the side instead, then the B is going to be over here and the C is going to be up here. So that's 2 positions where the 2 shapes are exactly the same. And if I rotate it again, then the C now is gonna come down here. The C is gonna be here. The B is gonna be the A is gonna be here, and the B is gonna be at the top. But these three things have the exact same shape, same dimension, everything. So this equilateral triangle is of rotational symmetry of order 3. There are 3 different positions it can be in that are exactly the same. Right? 3 different positions. So the rotational symmetry for that one is 3. For a circle, the rotational order is infinite. Infinite, because you have an infinite number of positions that you can rotate a circle in. And it is exactly the same. Alright? What other shape we can look at? Think you understand that little explanation there so far, guys? Understand that little explanation there?
Yes, sir.
Let's take a rectangle. Let's call this point here so 1. I'll call this point here so A. Call this point here so B. So that original position. If you rotate it, next position it can maybe be in is like that. But that is different from the first, right? And then you rotate it again, it can come down so that this turn all the way around here. So it's now like this. And the B is over here now, and the A is here. If you rotate it down like that. That's rotational order 2. There are 2 positions that it is in where the dimensions are exactly the same. Right? 2 different positions, 2 different positions they are in, but the dimensions are exactly the same. They look exactly alike in those 2 positions. Everything about them, dimension wise, the same. So the rotational symmetry for this one will be of order 2. Alright. So this question says they want a one that is of order 1. Alright, so this one says this one has no line of symmetry and has rotational symmetry of order 1. So it means that they can rotate and look the same. This is like the trapezium to me. It has no line of symmetry. Because look at it, it can eliminate by line of symmetry, you know. So this has a line of symmetry for sure, a kite has a line of symmetry down here. So use a line of symmetry as an argument. So this one has a line of symmetry. A square, as you know, has a line of symmetry. Everybody knows that. These are lines of symmetry. All those are lines of symmetry and a square. So it's not this is talking about rectangle, as you know, they have lines of symmetry. That's a line of symmetry. That's a line of symmetry. And the rhombus also has a line of symmetry, because the rhombus is also a square. A square is a rhombus, you know. But anyway, if you're looking at your typical rhombus, something like this. So the 4 sides are equal. That's a line of symmetry. Alright. So this also has a line of symmetry. So by process of elimination, this is the only one that has wouldn't have any line of symmetry. And I guess maybe the thinking of a trapezium will maybe shape like this. And there's no position it can rotate this in to look exactly like itself. So that's why the order is 1. Only one position it can be in to look like how it look now. Right? So I would say that one is a trapezium by a process of elimination. So this one is a trapezium. Next one says something has exactly 2 lines of symmetry and 4 right angles. 2 lines of symmetry and it has 4 right angles. So I guess it's this one. Rectangle really has 2 lines of symmetry. A lot of people think a rectangle. A lot of people think this is a line of symmetry, you know. It is not a line of symmetry. Because a line of symmetry, for example, this point here, if you draw a perpendicular to it, it's coming to here. If it was a line of symmetry, then the image of this point will be across from it over here. Right, so the diagonal is not a line of symmetry. So a rectangle, yes, has two lines of symmetry, one here so and one there so. And it has four right angles. So that's a rectangle. Second one is a rectangle. This one say it has one line of symmetry but no rotational symmetry. I think maybe why the trapezium could work for having one or the other one, because you can also draw trapezium like this. But then if I draw it like this, then it's gonna have a line of symmetry. Can have a line of symmetry. But that one kind of ambiguous in a sense, that first one. But anyway, so this one now has one line of symmetry but no rotational symmetry. So the one with one line of symmetry, I would say, is a kite. Now it has one line of symmetry down here. And when you rotate it, it can't look like itself again. Alright, can't look like itself again. So I would say those are the best answers. See the word best? Yeah, best. Best. Alright? Best. You're choosing the best ones. It's an information. The reason why I said best, because there might be arguments against some of these. Right? Because it all depends. For like trapezium, for example, it depends on which kind of trapezium you get. Because you can have a trapezium that has a line of symmetry. I can draw a trapezium like this. And then this would be a line of symmetry. If I draw a trapezium and this half and this half is exactly the same, it still has one pair of parallel sides. Right? So, but this says no line of symmetry. So, it all depends on which trapezium you think of. Anyway, that's what it is. This next question says, diagram below shows 4 straight lines, right, and 2 parallel lines. Now, once you have these parallel lines, these lines crossing them are called transversal lines, right? These are transversal lines. And when you have transversal lines crossing a parallel lines, you have all kind of angles that are related to one another. So you have, for example, Z angles, which are also called alternate angles. Our proper name is alternate angles, called Z angles. You have co-interior angles, which we call U angles. You have corresponding angles. You have vertically opposite angles, right? Some of them. So I'm going to give you some examples. So, for example, now, these two inside here would be co-interior angles. They seem to be in the bottom of this U-looking thing between those lines. They add up to 180 degrees. Co-interior angles. Alright? These two angles, they seem to be across from each other on the X there, and they are called vertical opposite angles. They are equal. Alright? So we can find 2 alternate angles now. So you come down this parallel line, go along this transversal line, and continue back down the other parallel line. You have now gone on alternate angles, which are these 2 angles now are equal. They are alternate angles, Z angles. Alright? So those are some of the things that we can have. You can also have what we call corresponding angles. Like you have these 2 parallel lines. Alright, so those 2 parallel lines. Alright, so I'm not seeing corresponding angles here. Alright, so you have that. Alright, no, so I'm not seeing corresponding angles here. Alright. Yeah, so I can use maybe this line down here crossing these 2. So this angle and this angle are corresponding angles. Right, because it's like this line is making the same angle with the two parallel lines. And the same way over here, it makes with this one, it's the same way over here, it makes with this one. So those two are what we call corresponding angles. Alright, so let's give you some examples and they will be equal. But let us go now and answer some of these questions. It said determine the value of angle Q and R. So angle Q and angle R. To me, angle R is quicker to get, right? Because these two angles are equal, vertical opposite. So I'll get angle R first. Maybe angle Q can be had first as well, but I'm going to get angle R first. So R is equal to 54. And you're asking us find the reason, just one mark for it. So R will be equal to 54 degrees, vertically opposite. These two angles are vertically opposite. They're opposite from on this cross. Right, so they're equal. And then now, having gotten the R, I know that this angle now is 180 minus this one, because those two are they are co-interior angles, these two. So the Q will be equal to 180 degrees minus the 54 degrees. Now I'm not saying this is the only way to do it, but that's the way I'm seeing right now, quickest way I'm seeing right now. I know that these two angles are co-interior angles, so I'm using that, right? So it's 180 minus 54, I get 126. 126 degrees. Alright, so far so good, everybody? Everybody okay?
Yes, sir.
Right. The next part now says, give a geometry quiz why P is 71 degrees. The alternate angles, right? These two, them two are equal. I'm not going to write alternate angles are equal. Simple as that. Right? Alternate Z angles are equal. Alternate because Z angles are equal. That's it. Done. We have this one now. It's a transformation. Alright. I've done this question a number of times, I'm sure, but anyway. So the diagram below shows triangle x prime, y prime, z prime, and x dot prime, y dot prime, z dot prime. So these are already images. Alright, they're already images. So that's an image, and that's also an image. Because the prime is on them. Right? It says the prime triangle, first one, is the image of triangle XYZ. So we don't know what XYZ is. We're going to have to put on the diagram. After an enlargement of scale factor 2 about the point at center 5, 1. So remember, the scale factor is 2. It means that this is twice as large as the original object, and also twice the distance away from the center point. Alright, so can do it two ways. You can say, okay, locate the center point and move these points halfway back towards the center point, because it means that the image would have been enlarged to that by 2. So let's put on the center point as a reference, 5, 1. So 5, 1 is right here. Right? So it's, for example, this point, its distance was doubled from here. So the original point is half of this distance. The scale factor was 2 that mapped it away from here to here. So how can we break down this distance? We can break it down into the components, the horizontal and the vertical components. So vertically, it is 1, 2, 3, 4, 5, 6. So the original object will be 3 up, and this is 1, 2, 3, 4, 5, 6 as well. So horizontal will be 3 as well, 3 up. So to find where the original was, we're going to go 3 up and 3 to the right. So these are different color for that. We're going halfway. So it's 1, 2, 3, and 3 across. 1, 2, 3. So this is where this point was. That's where Y is located. That's where the Y was, right there on the object. I said this distance was doubled by the scale factor. And then all we have to do, since we locate that point, can take this back off, is just draw a shape that is half of this size around this point. So this length was doubled by two units. So it means that originally it was 1 unit. So this is where X was. Right here. And then this length is 1, 2, 3, 4. So the object is 2. So that's where Z was, right here. And so this is your original triangle right here. Simple as that. That's the X, Y, Z. But then you must draw it, right? Draw the object. See there? X, Y, Z. But I can understand that. But I go do that.
Yes, sir.
Scale factor double the size and also double the distance. So our field to find by the original one is just half by the distance from the center, and then we just draw half the size around one point. I'll get it. Next part now says this triangle now is mapped onto the third triangle by a reflection in a line P, and I want us to state the equation of that mirror line. So this one is mapped onto this one by a reflection. I want us to locate the mirror line. The mirror line is going to be halfway between the points. So let me go and put half these distances. So this distance from here to here is 1, 2, 3, 4, 5, 6. So the mirror line is going to be halfway across from it. 1, 2, 3. So the mirror line is right here. And the same thing here. So half this distance as well. So the mirror line is this line. That's the mirror line. So that's a vertical line passing through 2. So the equation is x equals 2. Vertical lines carry equation x equals a number. Like the y-axis is x equals 0 is the equation of the y-axis. So any line vertical like the y-axis is x equals a number. So that line is x equals 2. X equals 2 is the equation of that line. X equals 2 is a red line P. Question 3 done. But to go to that, that's a quick and nice, easy question. But okay.
Yes, sir.
Then I told you to do number 9. To do number 9 next. I'm not going to do an entire paper today because I don't like the online classes to be too long. Right, we're going to make them long after March. Because then you don't have any choice, you have to be working. So, number 9 next. Which I think is, which question is number 9? This one, alright, yeah, this one. Alright, so I think I'm going to do this one. How long are we going, guys? How long are we going? What can you tell me? Started about 2. I'll do this question, I'll call it a day. Number 9. Maybe next time we'll do the others. Alright, number 9. It says the diagram below shows a circle with center P, a circle with points P, Q, R, and S lying on the circumference. And its center is O. Alright, center mark is O. It says RP is the diameter of a circle and AB is a tangent at a point P. Angle APQ is 3x, angle APR is 2x, and angle RPS is x. Then it says angle QSP is 54 degrees. So everything that they have said is in the diagram. So remember, this is centered on our knowledge. Doing this question is basically centered on our knowledge of the 7 rules of circle theory. Alright? Which we have already completed. And there are a number of ways to do this question. Question says, determine the value of each of the following angles. Show detailed working where possible and give an answer give a reason for your answer, right? Alright, first I want angle X. Alright, multiple ways to find angle X now. So, let me show you a number of ways we can find angle X. We can say, okay, the angle between a tangent and a radius is 90. So the whole of the angle over here so is 90 degrees. That's 5x. 5x. Because 2x and 3x is 5x. So we can say 5x equals 90 degrees. And so we divide by 5. So we can say x equals 18 degrees. That's one way. Another way you could say it is to say, okay, this 3x here is the angle between this tangent and this chord. This angle. And the chord is subtending this angle, the circumference. So we can use the tangent and chord rule. Angle between a tangent and a chord is equal to the angle subtended by the chord. And so that 3x would be equal to 54 degrees. And so if you divide 54 by 3 now, you get 18 again. 18 degrees, right? So I've given you two ways there. Let's see if we can have another way. This angle right here, let me see. Any other way? That's a 90-degree triangle. Alright, that's two ways you can find it, right? So two ways good enough so far. So whichever you want to do, good to go. So I'm gonna use 5x. I just use the 3x. Let's use the 5x. 2x. 2x plus 5x equals 90 degrees. 2x plus 5x equals 90 degrees equals 90. 2x plus 3x, Mr. Shaw. 2x plus 3x. So x equals 90 over 5, which is 18. Notice I'm not putting in a degree on the x because the question gave you x degrees. So x is just the value 19. Alright? So the angle is x degrees, but the x is just 18. And I'm using angle between tangent and radius is 90 degrees. Angle between tangent and radius is 90 degrees. That's what I'm using there. Alright, then we want angle y. Let's see, we're going to get angle y now. So angle y is up here. Alright, so angle y is subtended by this chord, and the same chord is subtending angle z. Alright, so let me tell you we're going to get angle y now. These two angles are up to 90 degrees. Why is that? Because this is a diameter. Diameter subtends 90 degrees at the circumference. So right here is 90 degrees. And total angle in that red triangle, in that blue triangle, is 180 degrees. This angle is already 90, so these two must be 90. So angle y becomes 90 minus x. Simple because the angle right here is 90 degrees. That triangle is a right angle triangle. So let's see that down here. So I'm going to say that angle y is equal to 90 minus x, which becomes 90 minus 18. So that is 72. So the y is 72 degrees. So I would say, firstly, this angle is 90. Angle subtended by diameter is 90 degrees, and that's why these two are up to 180. So angle RSP is 90 degrees. Tell him that first. That's because angle RSP equals 90 degrees because angle subtended by diameter is 90 degrees. Alright, and here what we were saying to get this is that total angle in the triangle is 180 degrees. Total angle in the triangle is 180 degrees. And one of the angles is already 90, so these two must add up to 90. That's the premise on it. Alright, then I want angle Z. So angle Z now, angle Z is equal to angle Y because both of them are subtended by this chord. Right, so angle Z is subtended by that blue chord at the circumference, and angle Y is subtended by the same blue chord at the circumference. They're also both subtended by this arc. So they want to say they're subtended by the arc or subtended by the chord. Both of them are subtended in the same segment, and so they are equal. Angles in the same segment are equal. So Z equals Y, which is 72. So here Z equals Y, which is 72. Reason is that angles in the same segment are equal. Angles in the same segment are equal. Alright. Then we come to this guy, which is bearings. I don't, yeah, bearings because I see the north line there. Question said, diagram below shows straight roads connecting towns L, M, N, and R. It says LR is 18, as you can see here. It says LN is 12, you can see that there. MN is 10, you can see that here. And angle RLN is 25 degrees, you can see that there. And angle LMN is 88, you can see that there. And then I give you this bearing. That's a bearing from L to M. L to M direction is on the bearing of 50 degrees, 50 degrees. It says calculate angle MLN. That's this angle inside here I want. MLN. Alright. I'm going to call it alpha. I'll put on the diagram as alpha. So find it. I have the angle, right? So because in this triangle now, I have this pair of angle and side opposite each other. I know both of them. I can use the sine rule. So I'm using the sine rule, that pair with that pair, sine rule. Alright, so tell the examiner, sine rule. Use sine rule. I'm going to say sine of alpha, or the side opposite the alpha is 10, equals sine of the angle that we know, sine of the 88 degrees over the side opposite the 88 is 12. Then to find the alpha, I want to take the 10, multiply it up here, and enter the inverse sine. So work with me now. The alpha becomes sine to the minus 1. Sine to the minus 1 of, this 10 goes up here. 10 times the sine of 88 degrees over the 12 under here. And put that in the calculator and I have the answer. So it's going to be sine to the minus 1 of a fraction when the fraction is 10 times the sine of 88 degrees, and then putting that over 12, that becomes 56.4 degrees. 56.4 degrees. That's it. 56.4 degrees is the answer for alpha. And let me just put on the diagram now that we know it. This angle is 56.4 degrees. 56.4 degrees. Is that angle, right? Continuing, it says calculate the length, the distance NR. So NR now, that's this side. Find NR now, gonna work in this triangle now. And because we have two sides, the angle between, we're gonna use cosine rule. That's capital, that's a common case for use of a cosine rule. Remember, cosine rule starts out like Pythagoras theorem and then subtract that piece, right? So let's write it here so it's in front of us rather than go over to the next page. Let's write it and then copy it down. So using cosine rule for NR, cosine rule. So it's going to be that NR squared first is equal to, start like Pythagoras theorem, 12 squared plus 18 squared. 12 squared plus 18 squared. But it's not Pythagoras theorem, so if you subtract a piece, you subtract twice the product of the two sides, 12 and the 18, and you cosine the angle between them, which is 25 degrees. 25 degrees. And then instead of squaring both sides, you could square root this and take out the square and then square root this over here. Alright? And then let's work out NR from that. And one calculation instead. So we're going to square root everything. So it's going to be 12 squared plus 18 squared minus, and that is 2 times 12 times 18 times the cos of 25. And that is 8.3 significant figures is 8.75 kilometers. And this is what we need down there. Cut this. Place it down here. That's it. Alright. So determine the bearing of T of R from L. So remember now, R is not the from position, so it's from L to R, the direction L to R. We want the bearing. L to R, that direction. We want the bearing. L to R. So let's see what it is in the diagram. L down to R. That's easy. Bearing L to R is all of this angle here. So stand at the from position, you want the bearing down to there. Stand at the from position and measure the clockwise angle from the north direction to the direction you want the bearing in. So that's that angle. So that bearing angle is the sum of these three angles. So it's 50 degrees plus 56.4 degrees plus 25 degrees. That's the bearing that I want. So that must be 1 mark. That must be 1 mark. Yes, 1 mark. You can see it down there. 1 mark. 1 mark. So very easy. They didn't have much bearing in this question. Sine rule and cosine rule mainly. That's it. Let's work out 50 plus 56.4 plus 25. 131.4 degrees. And now I just go 3 digits. 131 degrees as the answer. Let's go 3 digits. That's it. Let's correct the nearest 3 digits. That's it. Body good? Body okay
Yes, sir.
there? Alright. We did that question relatively rather quickly. Which one's the next one I wanted? I said number 10 next. 9 and then 10. I'm going to number 10 and then we'll call it a day. At least I would have done more than half the people. 1, 2, 3, 4, 5, 6. I'll go to number 10 and then we'll call it a day for sure. Alright? Number 10. So getting a revision. And here's number 10. A vector question. Alright, it says 3 points. O, P, and R are shown in the grid below. O is the origin. Alright? Question says write the position vector of R, O, R in this form. Remember, position vector and coordinates have the same value. Same values. So R is this point. Let's put on there. R is the point 5, 1. 5, 1. So the position vector will have the same values written in a column vector format. So it's simple. Just don't need no calculation. Just write it down. See, right. No calculation needed. OR is going to be 5, 1. Like that. Right? And while we're at it, we can just write what OP is as well. So P over here is a point minus 2, 4, as you can see. Minus 2, 4. And so OP, position vector of P, have the same values. Minus 2, 4. Alright, that's OP. Question says another point Q is located such that QR is 2, negative 4. Use this information to plot the point Q on the diagram. So see it, you know, simple. Q to R is 2, negative 4. But we have the point R, you know. So what we can do, if we want to use the information to plot, we can reverse this direction and go from R to Q instead. And R to Q is just going to be the negative of this. We're going in the opposite direction. So it's going to be minus 2, 4. So it means you go from R to Q, it's got 2 to the left and 4 up. That's what this minus 2, 4 means. 2 to the left and 4 up. 2 to the left and 4 up. Starting at R, that's how we reach Q. Alright, so that's what we're going to do on the graph to locate where Q is. Alright, so 2 to the left, 4 up from R. So from here, we're going to go 2 to the left, 1, 2 units to the left, 4 units up. 1, 2, 3, 4. So Q is right here. And Q coordinates is 3, 5, as you can see. 3, 5. 3, 5 are the coordinates of Q. So we go 2 to the left, 4 up. Alright. And that is it. Alright, 3, 5. So plot the point. So Q is the point 3, 5. Could have also calculated it. Let me show you some calculation we could have also done rather than construct it on the diagram. So they give us this equation. Right? They say QR is 2, negative 4. And we're trying to find OQ. So we're going to split this vector equation and write it as O times the last, OR, minus O times the first, which is OQ. And put that equal to negative 4. I want to make this a subject. So we could bring this over this side and then bring this over that side. So we will get the OQ. And this side equals, this stays OR minus this vector come over here as 2, negative 4. What is the OR? The OR is 5, 1. So then it will be 5, 1 minus 2, negative 4. That will be the OQ. If you do this calculation, it's 5 minus 2 is 3. And then 1 minus give you a plus 4. That becomes a 5. And that's what your OQ would be. 3, 5. And if OQ is 3, 5, then it means that Q is a point 3, 5. If the position vector is 3, 5 like that, then Q is a point 3, 5 like this. So that's another way you could have done it by calculation. But you could easily get it from the graph. And I can remember the vector is just how you go from the point R to point Q. And this means 2 units to the left because it's negative. This means 4 units upwards because it's positive. Alright, that's that. Let me take it, this is the answer. I have located it. Next part now says determine the modulus of QR. That's the length of QR. So QR is this vector. So we could calculate it and do square root of this squared and that squared. So QR, remember, is negative 2, 4. QR, right? No, it's 2, 4. 2 negative 4, sorry. It's 2 negative 4. Modulus is just the length of it. So modulus of QR is just the square root of the 2 squared and the 4 squared. And that's 16 and 4 is 20. Square root of 20 units. That's how long it is. Modulus is length. Magnitude of modulus is length. That's what it is. Alright? It's referring to the length of it. Next part, now show by calculation that this is a parallelogram. Now remember, if it's a parallelogram, it has 2 pairs of equal opposite parallel sides. Alright? So let's look at the diagram. OPQ as a parallelogram, the opposite sides are equal in length and parallel, so the opposite sides are equal vectors. That's what we need to show, that the opposite sides are equal vectors. So we're talking about this parallelogram. Let me draw it in blue. Show that this is a parallelogram. So the opposite sides must be equal vectors. What are the opposite sides like? This one and this one must be equal. Right? So the OP has to be equal to the RQ. And then this one has to be equal to this one. That's the OR has to be equal to the PQ. OR has to be equal to the PQ. So this is all we need to show, that we have a parallelogram. That's what we have to show, that the opposite sides are equal vectors. Alright, so let me copy this down and say we have to show this and show it. Alright, so put it over here. So I tell the examiner we need to show this. Need to show this thing. I think we have one already. I think we have an OP equal RQ already. So we did write down OP. So the RQ is this, negative 2, 4, and the OP is the same thing, negative 2, 4. So we have those on the paper already. So we have this already. So we can take that off. Now we need to show that the OR and the PQ equal. We know what OR is already, you know. So OR was equal to this, 5, 1. So we need to show that PQ is equal to 5, 1. So this is what we need to work out. Alright, so let's work it out. The PQ would be OQ minus OP. And the OQ is 3, 5, as we said. Here is it, 3, 5. 3, 5, this is 3, 5. Minus the OP is, OP was minus 2, 4. Minus 2, 4. Minus 2, 4. Minus 2, 4. When you do this calculation, you're going to get 3 minus a negative 2 becomes 3 plus 2 is 5. And then 5 minus 4 is 1. And 5, 1 is actually what the OR is. So this is also shown. and therefore we can conclude that yes, OPQR is a parallelogram. Alright, by showing this. That's it. Alright, then we come down here. It says calculate the value of x and y in the matrix equation. Alright, so basically that's a 2 by 2 matrix multiplying to give you this 2 by 2. Well, product of two 2 by 2 matrices given this matrix. Now what we're going to do is recognize that this value is a product of this row and this column to get the x. And then we're going to use this value is a product of this row and this column. That's what we're going to do, right? So I set it up. This row and this column equal to x. So you can say 1, 5. I can turn the other way around. X equal those two. So the x is equal to, I'm not working to that. The x is equal to 1, 5 times column minus 4, 2. So the x equals, you multiply them. First element times first element, then second element times second element. So it's 1 times negative 4 is negative 4, and 5 times 2 is 10. That becomes a 6. So the x is equal to 6. 10 minus 4 is 6. Simple as that. And then now, y, you can use this row and this column equals the 6 to say what the y is, right? So you can set that up and say this row 2y times this column minus 4, 2 is equal to this 6 right here. And you work it out and solve for the x. So it's first element times first element. That's 2 times negative 4 is negative 8. And second element times second element. That's y times 2 is 2y. That's all equal to 6. Take this negative 8 and carry it over and add it. You get 2y equals 14 when you add it. And then you divide by the 2. You get y equals 7. 14 divided by 2 is 7. That is it. But go to that. Equality of matrices, you call this method. But good?
Yes, sir. Yes, sir.
Alright. We'll come down here now to part C. It says a transformation T is represented by this matrix, and you're supposed to know that that is a y equals x reflection matrix. I just see it. What it does, it reverses the coordinates. You see it? 2, 5 goes to 5, 2. It reverses the coordinates. It maps a point xy onto a point yx. The more things you know, the better. Alright? More things you know, the better. It says describe the transformation. That's a reflection line y equals minus y equals x. That's all. Easy. Reflection line y equals x. Reflection in the line y equals x. That's all. 2 marks for knowing that, you know. Just look at knowing this matrix. You don't have to work it out. You don't have to figure out nothing. That's it. Reflection in the line y equals x. That's the power of knowing the matrices that you're supposed to know, that I gave you. And you must know sheets to know. Alright? 2 marks for us knowing that. Look at that. Alright guys, I'm going to end it there. And we have class tomorrow. Remember, for tomorrow's class, make sure you bring your ruler, and your handout, and an eraser, and a pencil. Alright? You must bring your ruler, your handout, pencil, and eraser for what we're going to do. If you don't bring those things, you cannot participate in the class tomorrow. So make sure you bring them. Make sure you have them. Alright everybody? That is it for today. So I'm gonna end it now. See you in class tomorrow and Monday. Bye, everybody.